Which even let me preface what we did like yesterday. So like we did word problems where the goal was you're trying to solve. So you're trying to find your x-intercept. So you're trying to find whatever x is, whether it's two numbers in a sequence, like this whole first page, or maybe it's like a shape and you're trying to find the dimensions. The goal was, can you put it into a trinomial and then solve it using product and sum or quadratic formula? Come on in. Same goal today, but we're looking how a shape may change dimensions as well. So for example, this one, a lot of you go to the cottage, so you would know a rectangular floating dock, those things that float in the middle of a lake. It measures 4 meters by 5 meters, and it says a new dock is gonna be made by extending each side length by the same amount. Here, do you need two? One for Alex or just one for you? Oh, thank you. So they're gonna extend all the side lengths, and it wants to know what are the new dimensions of this brand new dock that they're building. So again, we're always gonna start with a diagram. We gotta visualize this. So like, here's my original dock.
Wait, each side by the same amount. So it'd be 5 plus x, 4 plus x, 4 plus x.
You're gonna see that. So 4 meters by 5 meters. I'll put my little M here. And then like Abby said, each side length is getting extended out. So like, okay, if I extend this side length this far, if I'm extending this side length out, I'm extending this side length out.
This one's easy.
Okay.
Right? So all the side lengths have been essentially like given an extra dimension. We don't know what it's been extended by, but we just know it's been extended all the way around for it to create essentially like this new border where like this is your new floating dock.
Wait, so is it 4 plus x and that's like squared together?
You're so
Are you allowed
close.
to just like, no, like, can we just put what we think it is?
You're so close, Stone. And what do you mean? You want to just like put the equation in?
Because like, well, I know that 7 times 6 equals 42 meters squared. So each side got increased by 2 centimeters. 2 meters.
I know, but how do you prove that?
You have to prove it.
Yes. How do you prove that?
Can I prove it after?
We're gonna show it. So okay, like Abby said, so you said each side got improved by or like extended by like what, 2?
2.
We don't know at this point in the problem solving process, assuming like we're not thinking that far, that it got extended by X amount of meters. We don't know how many meters it got extended by, but X we're gonna use there. So this side length is now gonna be 4 plus 2x for each extension on each side. And same thing, this side length is now gonna be 5 plus 2x, because it was 5 meters plus the 2 extensions on both sides. Is that okay how I just built that?
Yes.
Yes, that's okay. So the 2x is for the each extension on both sides, right? It tells me that we're talking about area, right? It mentions the area of this new dock is 42 meters. So if it's hinting at area, I should probably use the area equation, which, what is even the area of a rectangle?
Height times length.
There was a mixture of stuff. Yeah, length times
Same
width.
thing.
Yeah, same thing. So, okay, area is equal to, and I'm just gonna plug in, let's say this one's my length and this one's my width. So I'm gonna say 5 plus 2x and 4 plus 2x. And it actually also told me what the area is. So I know that A can be 42. So I'm gonna sub in 42 for A. So I'm setting my whole area equation equal to 42. And then I just gotta FOIL. I'm drawing the arrows.
20.
That's the whole shebang. So yeah, tell me. Okay, so Jack 20, and then what? Plus what?
10x.
Yep.
And then
8x.
8x. And then 4x.
4x squared, because x times x. Perfect. We can combine some like terms here. So like on the other side, on the right side, I see like my two middle terms can go together, 10x and 8x. So I'm gonna simplify that to 18x. And then in order to solve something, it has to equal 0. Our whole equation has to equal 0. So what do we gotta do with that 42? Move it over. Exactly. So this is gonna be minus 42 now.
Can't you take 4 out of every? No.
So I'm just like rearranging it, right, to have x squared in front. So then we'll see, okay, we're gonna be left with 4x squared plus 18x, and then 20 minus 42 gives me negative 22. And then this is where I give you the option of like, you could try doing it with product and sum if they're nice numbers and it comes to you fast, or you could go straight into quadratic formula. Abby, what did you say about the numbers that you notice? Is there anything you can take out of these numbers that maybe make your life a little easier?
2.
Yeah, I think 2. We could take out a 2, and if we divide everything by 2,
Wait, sorry, why do you have to do the 2x instead of just 4 plus x?
4 plus x?
4 out of the bracket.
For here, for our dimensions?
Yeah.
Because we got an extension on both sides, so it extended this way and this way. So on both ends of your width and your length, you got extension. So that's why it's 2x, not just x, right? Okay, so as I was saying, we're factoring out 2 out of everything. So this is all dividing by 2. Makes your life a little easier. And then that is what you can do quadratic formula with, or product and sum with. I'm not a fan of product and sum. I don't want to do it. I'm so tired. I'm just going to go straight into quadratic formula. I also don't think you can use product and
Are
sum
you
with
gonna
this
give
one.
us the formula
I am.
on the test?
I will give you. Yeah. So, okay, we've got our A, B, and C values.
What times to negative 11?
Yeah, I was going to say times to negative 22 and adds to 9. I don't think there's a lot of numbers that can do that. I don't think there is. So I'm going into straight quadratic formula. So, okay. I'm going to do that over here and give myself some space. So I'll remind you it's x equals negative b plus minus the square root b squared minus 4ac all over 2a. I
Wait,
hate
sorry,
saying
say it
that.
again?
No, that was my one and only. There you go. I know I sang it on the first day, but now I'm like feeling like a little sick in my throat, so I'm like not sounding on par. So, okay, I'm using these values, my A, my B, my C, right? So, okay, I've got negative 9 plus or minus the square root.
Yes,
Mhm. 9 because we factored out 2. We made the numbers a little smaller.
Oh.
If you just went straight into quadratic formula with like 4, 18, and negative 22, you would have the same answer. You would just be dealing with bigger numbers. That's all.
8 instead of 18, so I thought it was 4.
That's okay. It's okay. 9 squared minus 4 times 2 times our C value, which is negative 11, all over 2 times A. So 2 times 2. Right? And then I'm going to just simplify. So I'm like, okay, under the square root, what do I end up getting? I get negative 9 plus or minus. 9 squared is 81. And then I have minus negative 88. Right, when I do 4 times 2 times negative 11, that gives me negative 88. So I know that I'm going to end up adding those two numbers, because when we subtract a negative, it turns positive. Which you'll see, oh my god, under the square root we get 169, which is actually a square rootable number. It's nice and pretty. It's a whole number.
Wait, never mind, I got it.
You want to pull a desk out there? Okay. You can take that one. Yeah, that's no problem. Okay, which did you do? Square root 169? Do you know what that is? Oh, thank you, man.
Smash.
A little higher. It's a prime number.
14.
Closer. So close. 13, exactly. So it's negative 9 plus or minus 13 divided by 4. And then I got to do my two options. I have to see which one works. Okay, option 1, let's say if I add 13. So negative 9 plus 13 divided by 4. If I do that, negative 9 plus 13 is 4. And then 4 divided by 4, 1. So it could extend by 1 meter. That's one option. And then if I do option 2, that's when I'm going to subtract. So I'm going to say negative 9 minus 13. But we're going to see this gives me an even bigger number. This is going to give me like negative 22 all over 4, which that is extraneous, right? As a decimal, what is this? Did you get this? 22 divided by 4 is negative 5.5. Right, so does not make sense. A dock cannot be negative 5.5 meters wide. So it is extending 1 meter on both sides.
Wait, I'm not that,
Don't worry, I'm not going anywhere.
I'm just going, I'm going.
So your last step is now just saying, like, tell me the dimensions of this dock, right? So the length we said was 5 plus 2x,
I don't have any room.
which is 2 times 1. So 5 plus 2, which is 7. And your width, right? We have 4 plus 2 times 1. So 4 plus 2, which is 6 meters. So those are the new dimensions of your dock. It's now 7 by 6. Perfect. What are you waiting for? A calculator?
I lost my pencil case. I don't know where I
No way.
got a calculator, but I need a pencil.
Okay.
I'm one for two.
So these are kind of like your steps. Diagram and show the extensions of whatever you're growing by. Use whatever formula it's telling you. So if it's inferring area, use area. If it talked about perimeter, you'd use perimeter. If it talked about circumference for a circle, it would be circumference, right? Yeah, well,
Question.
number 4 is just me plugging it in to our dimensions. Yeah, Jack?
With this one, oh, never mind, I understand it, because the X one is when you use.
Exactly, right? And then again, quadratic formula, or you could do product and sum. In this case, quadratic formula was our friend.
Wait, why are you 5 plussing 2? Where's the 2?
So this was our dimensions for this new doc. We said it was gonna be 5 plus 2 and then 4 plus 2.
Oh, yeah, but
And that's me
2X.
just plugging in 1 for X to say like it got extended 1 meter on both sides. Okie doke? I'm gonna give Hannah her quiz, but for this one, it's the same scenario, very similar, where you've got a picture that measures 10 centimeters by 5 centimeters, and it's gonna be it's gonna have a border, like in a frame around it. You know those like white borders around pictures? It's gonna have that, and it says the width of the border is the same on all sides, so it's like equal width all the way around. And I want you to try and draw that in a diagram. We'll get into solving together, but see if you can try visualizing it, okay? And then I will be right
Do you want
back.
to eraser too, by chance?
Yes, that would be good. And then can you check your phone here, Shannon?
It's in my bag.
Can you still check
Yeah.
there? Yeah.
If there's no one,
Wait, where did you tell me to check?
It's on the phone, on the
Oh, there is
cell
one.
hotel.
Wonderful.
I'm gonna set a timer. Okay, how did we draw? Yeah, perfect, yeah.
I have a question. Like, if I did it a different way, but I still like prove like how I did it. Yeah, I know, but
It doesn't use any quadratic.
yeah, I know.
I would specify use methods learned in class. You could use that as a backup, as like a way to like,
But it's
Helps
so
you get
much
there,
easier,
confirm your
so much, like,
answer.
faster. So if I did this on a test, I would get it like wrong,
yeah, give you like a mark.
just for the right answer.
Yeah. Okay, how did we draw these?
Find like a new way to do it.
Did we draw these scenarios? Yeah, it's the same thing. Okay. Oh, hello, come on. Here, swap. Okay, shall we do this last one? Because this one, there's more steps in this case. So, okay, we're gonna start with a diagram because visualizing this definitely helps. So step 1, I'm drawing it. So here's my picture, right? And I know that it's friends. Okay, this is only gonna take like 5 more minutes and then I'm sending you on your way. So we know that our picture is 5 centimeters by 10 centimeters, right?
Quick question.
You can ask her, but she only gets 40 minutes. Yeah.
Does it matter, which
No.
way?
If you want to put it vertically, horizontally, doesn't matter which way you want to put your picture. I just drew it this way. And then we said the whole border is around it. So again, it's this idea of like each side length is getting extended out. So I'm going to draw my little arrows. I don't know how much it's getting extended out by or how wide this border is, but I knew that my border is going to look something like this all the way around. Right? Okay, perfect. So again, I extended this by X centimeters on both sides. I don't know how many centimeters. That's our unknown thing. So my width is now going to be 5 plus 2x, so same thing as we did last time, and same thing, 10 plus 2x.
Wait, can I move 2 bracket x plus 5?
No,
Damn it.
because then that would change that dimension and this dimension, because then you'd essentially be doubling it, yeah?
Why can't you just use like?
But it is doubling.
Hold on, but we're gonna get to that.
Expand on one side. Why
Yeah, you get the same answer.
If you expand both on one side, but then you're not having, if you only expand on one side, which you don't have to draw this, friends, please, let me get through this. If you expand on one side though, and this is your picture, have you ever seen a picture frame that has a border like this?
Yeah, but
Yeah, but that's just still a dimension. Yeah.
Exactly, so then can't you draw it all the way around? Visually, that I think makes more sense, to have a uniform width all the way around the picture.
Biologists are killing me.
it says they're supposed to be the same size, like all the sides are the same.
Exactly, so meaning this, friends, can we please stop talking? I asked nicely like 4 times, thank you. This is a uniform width. Again, think about a picture in a picture frame. Would you ever see a picture like this? I know you can just shift the picture then to the middle, but the idea of like, why would you draw and put a picture in a picture frame like that?
And you also don't have 4 sides.
It's off, yes, for the calculations, but I'm saying for a diagram, like logically, this would not come to most people. I may say include in diagram. Yeah, so like that, I would say that's not a border all the way around a picture. That kind of doesn't make sense. Whereas this one, it's like you can see the picture is centered and you've got the border all the way around it. That is logically like how we see pictures, right? So there's a couple steps that we need to think about here because it gave us a lot of information. It told us a picture, it told us a border, and then it just wants to know the width of the border. So I just want to know just X. Pardon?
Like how thick?
How thick is this border? Like how much is it getting extended on both sides? So first of all, it would probably be helpful to know like what's the area of this picture, right? So I'm gonna say a pic, which it's still a rectangle, so I'm still just doing length times width, right? So the picture is 5 by 10. So I'm just gonna say the area of the picture is 5 cm times 10 cm. So altogether, it's gonna be 50 cm squared. Okay, that's my area of the picture. Now I'm thinking about the bigger rectangle that we have. That's the picture and the border together, right? So if I have a pic plus border, so that's the whole big rectangle with these new dimensions. It's still a rectangle, so I'm still doing length times width, but now I'm gonna use these outside dimensions. So the 5 plus 2x times 10 plus 2x. So that's what I'm gonna put in here. So 5 plus 2x and 10 plus 2x. And we're gonna FOIL. So like, okay, if I FOIL this, you tell me, what do we end up with? You can yell it at me, it's okay.
4x squared plus 30x plus 50.
Okay, I'm gonna even go a step back and do like the order that we get. So like 5 times 10, 50, 5 times 2x, 10x, 2x times 10 is 20, and then 2 times 2, we get 4x squared. Perfect, that guy. Right, and then if we rearrange, we're gonna say, okay, Abby, you said 4x squared plus 30x plus 50. So that's us grouping like terms, yeah?
It says that the area of the border is twice the area.
I'm getting to it, if you'll let me get to it. Okay. Okay, Jesus, okay. So, step 1, we've got the area of the picture. We've got the area of the whole border in the rectangle. So if I want to find what the area of just this like strip is around it, so just the area of the border, so a border I'll call it, we're basically going to take big rectangle minus little rectangle, and that's just going to give you an expression for just the border, right? So basically just this shaded bit, if I do it in like a blue highlighter, ooh, that's a little too big. I want to do it like this. So it's like we're finding an expression for just this part of the picture frame, which is what we want to find. We care about what the border is. So I'm going to say a pic plus border. Ooh, that's an A. Oh my God. A, there we go. Pic. I want to make this legible. Plus border. And then minus the picture. So it's like I'm doing the whole big rectangle, that essentially like that pink outline, minus the rectangle in the middle, the picture, and that'll give me the shaded blue area. So I'm just subtracting them from each other. So I'm gonna take the 4x squared plus 30x plus 50, and then I'm gonna minus the area of the picture, which is just 50. Okay, anything I can cancel out or simpler?
Yeah,
Yeah, what?
that'll just be 4x squared plus 30x.
Done, right? So that is gonna be my area of the whole border around the picture. So
Now
4x
that
squared
all that x equals-
plus 30x. Now I'm getting to the bit that Eamon said, which is it tells us in this sentence here, right, which I'll highlight in yellow, the area of the border is to be twice the area of the picture. So now we know what the area of the border is. That's what we had to solve for first. We couldn't just jump to it with step number 2, because that would include the picture. So that wouldn't be right. We just want to know the area of the border around the picture. So I'm gonna set that equal to 2 times the area of the picture. So we said area of the border is equal to 2 times the area of the picture. So I know the area of the border, it's this expression, 4x squared plus 30x. And then I know that my area of the picture is just 50. So 2 times 50. Which 2 times 50, what do I get? 100.
Wait, I feel like, wouldn't you just, what if you, did like, you know how we had like 4x squared plus 30x plus 50? Why didn't we just set that to the area of 150? Because we already know 50 plus.
But where does 150 come from then?
Because, well, we know that if the area of the border is double the 50, then it's 100, obviously.
Yeah,
So 100 plus 50 is 150. So that's the whole border of the whole
but I
thing.
don't need 150.
Yeah, but if you did 150, then you move it over and you get that answer. You'd get minus 100 equals 0.
But in this case, I still need the area of the border, right? This is the area of the picture. This is the area of the picture with the border, your big rectangle, but you can't include the area of the picture in that expression because this is including the whole thing, like this entire thing. I can't include the area of the picture in this. I just want the shaded area around the picture. So that's why it's like we have to do each of these steps. I can't just jump and say, okay, this one, and then I'm setting it equal to 100, because then that's not going to equal this expression here. You will not get the same thing, right? So it is more steps, considering you have to be like, I'm going to find the picture of the, or the area of the picture. I have to find the area of the entire picture with border, and then you have to subtract them because you just want the shaded area around it. That's what we're solving for, just the blue. And then that's where we say, okay, now I'm gonna set it to 2 times the area of my picture. So this is your final expression for just the shaded blue area. This is the one you're gonna do quadratic formula on, or product and sum if it works, but I don't think you get a nice number. I ended up getting decimals. So I would say quadratic formula it. Would you like to try doing quadratic formula on your own and seeing if you can find the dimension? Yes, Alex?